Section 4.4, Adding and Subtracting Fractions. In this video we will see a visual argument for adding fractions and how to add fractions with common denominators, how to subtract fractions with common denominators, how to find the least common denominator, the LCD, of two or more denominators, how to add or subtract fractions with different denominators, the definition for the multiple of a number, how to find the least common multiple or LCM of a set of numbers, how to find the LCM with prime factorization, and how to compare fractions. Paul and Tony order a pizza, which has been cut into 8 equal slices. Thus each slice is 1/8 of the whole pizza. Paul eats 2 slices, shaded in light gray, in figure 4.13, or 2/8 of the whole pizza. Tony eats 3 slices, shaded in light red, in figure 4.13, or 3/8 of the whole pizza. It should be clear that together Paul and Tony eat 5 slices, or 5/8 of the whole pizza. This reflects the fact that 2/8 plus 3/8 equals 5/8. This demonstrates how to add two fractions with a common or same denominator. Keep the common denominator and add the numerators. That is, 2/8 plus 3/8 equals 2 plus 3/8 equals 5/8. Adding fractions with a common denominator. Let a over c and b over c be two fractions with a common or same denominator. Their sum is defined as a over c plus b over c equals a plus b over c. That is, to add two fractions having common denominators, keep the common denominator and add their numerators. A similar rule holds for subtraction. Subtracting fractions with common denominators. Let a over c and b over c be two fractions with a common or same denominator. Their difference is defined as a over c minus b over c equals a minus b over c. That is, to subtract two fractions having common denominators, keep the common denominator and subtract their numerators. Example 1. Find the sum of 4/9 and 3/9. Solution. Keep the common denominator and add the numerators. 4/9 plus 3/9 becomes 4 plus 3/9, and 4 plus 3 is 7. So 4 plus 3/9 equals 7/9. Example 2. Subtract 5/16 from 13/16. Solution. Keep the common denominator and subtract the numerators. So in the numerator, 13 minus 5 is 8, so the result is 8/16. Of course, as we learned in section 4.1, we should always reduce our final answer to lowest terms. One way to accomplish that, in this case, is divide numerator and denominator by 8, the greatest common divisor of 8 and 16. So in the numerator, 8 divided by 8 is 1, and in the denominator, 16 divided by 8 is 2, so we're left with 1/2. Example 3. Simplify 3/x minus a negative 7/x. Solution. Both fractions share a common denominator, x. Add the opposite, change minus a negative 7/x to plus 7/x, then add the numerators. 3 plus 7 is 10, so the result is 10/x. Adding fractions with different denominators. Consider the sum 4/9 plus 1/6. We cannot add these fractions because they do not have a common denominator. So what do? We do. Goal. In order to add two fractions with different denominators, we need to first find a common denominator for the given fractions, and second, make fractions with a common denominator that are equivalent to the original fractions. If we accomplish the two items in the goal, we'll be able to find the sum of the given fractions. So how to start? We need to find a common denominator, but not just any common denominator. Let's agree that we want to keep the numbers as small as possible and find a least common denominator. Least common denominator. The least common denominator, LCD, for the set of fractions is the smallest number divisible by each of the denominators of the given fractions. Consider again the sum we wish to find, 4/9 plus 1/6. The denominators are 9 and 6. We wish to find a least common denominator, the smallest number that is divisible by both 9 and 6. A number of candidates come to mind. 36, 54, and 72 are all divisible by 9 and 6, to name a few. But the smallest number that is divisible by both 9 and 6 is 18. This is the least common denominator for 9 and 6. We now proceed to the second item in goal. We need to make fractions having 18 as a denominator that are equivalent to 4/9 and 1/6. In the case of 4/9, if we multiply both numerator and denominator by 2, we get in the numerator 4 times 2 is 8, and in the denominator 9 times 2 is 18. In the case of 1/6, if we multiply both numerator and denominator by 3, we get in the numerator 1 times 3 is 3, and the denominator 6 times 3 is 18, so 3/18. Typically, we'll arrange our work as follows. 4/9 plus 1/6 equals 4 times 2 over 9 times 2 plus 1 times 3 over 6 times 3. 4 times 2 in the first fraction is 8, and 9 times 2 in the denominator of the first fraction is 18. 1 times 3 in the numerator of the second fraction is 3, and 6 times 3 in the second fraction denominator is 18. Now we have two fractions with a common denominator, so we'll add the numerators, 8 plus 3 to get 11, and the result of 11/18. Let's summarize the procedure. Adding or subtracting fractions with different denominators. First, find the LCD or least common denominator. which is the smallest number divisible by all the denominators of the given fractions. 2. Create fractions using the LCD as the denominator that are equivalent to the original fractions. And 3. Add or subtract the resulting equivalent fractions. Simplify, including reducing the final answer to lowest term. Example 4. Simplify. 3 over 5 minus 2 over 3. Solution. The smallest number divisible by both 5 and 3 is 15. So the LCD is 15. To turn them into equivalent fractions, we'll multiply the first fraction by 3 since the denominator is 5, and the second fraction by 5 since its denominator is 3. So multiplying, the first fraction becomes 9 over 15, and the second fraction becomes 10 over 15. Now that we have two fractions with a common denominator, we can subtract the numerators, 9 minus 10, to get negative 1, and the resulting fraction, negative 1 over 15. Although this answer is perfectly acceptable, negative divided by positive gives us a negative answer. So we could also write negative 1 over 15. Example 5. Simplify negative 1 over 4 minus 5 over 6. Solution. The smallest number divisible by 4 and 6 is 12. So the LCD is 12. So we'll multiply the first fraction by 3 since the denominator is 4, and the second fraction by 2 since the denominator is 6, so that we'll get equivalent fractions with the denominator of 12. The first fraction becomes 3 over 12, and the second fraction becomes 10 over 12. Now that we have fractions with common denominators, we can subtract the numerators. Negative 3 minus 10 would be a negative 13, so our result is negative 13 over 12. Example 6. Simplify. 5 over x plus 3 over 4. Solution. The smallest number divisible by both 4 and x is 4x. So the LCD is 4x. To get equivalent fractions with the denominator 4x, we'll multiply the first fraction by 4 since it has denominator x, and the second fraction by x over x since it has denominator 4. So the first fraction becomes 20 over 4x, and the second fraction becomes 3x over 4x. Now that we have two fractions with the common denominator of 4x, we'll add the numerators. 20 plus 3x is just 20 plus 3x. We can't combine them because they're unlike terms, so we're left with a fraction 20 plus 3x over 4x. Example 7. Simplify. 2 over 3 minus x over 5. Solution. The smallest number divisible by both 3 and 5 is 15. So to get equivalent fractions with the denominator 15, we'll multiply the first fraction by 5 over 5 since it has denominator 3, and the second fraction by 3 over 3 since it has denominator 5. The first fraction becomes 10 over 15, the second fraction becomes 3x over 15. Now that we have two fractions with the common denominator 15, we can subtract our numerators to get 10 minus 3x over 15. Least common multiple. First we define the multiple of a number. Multiples. The multiples of a number d are 1d, 2d, 3d, 4d, etc. That is, the multiples of d are the numbers in d where n is a natural number. For example, the multiples of 8 are 1 times 8, 2 times 8, 3 times 8, 4 times 8, etc. Or equivalently, 8, 16, 24, 32, etc. Least common multiple. The least common multiple, or LCM, of a set of numbers is the smallest number that is a multiple of each number of the given set. The procedure for finding an LCM follows. 1. List all of the multiples of each number in the given set of numbers. 2. List the multiples that are in common. 3. Pick the least of the multiples that are in common. Example 8. Find the least common multiple, or LCM, of 12 and 16. Solution. List the multiples of 12 and 16. The multiples of 12 are 12, 24, 36, 48, 60, 72, 84, 96, and so on. The multiples of 16 are 16, 32, 48, 64, 80, 96, 112, and so on. Pick the common multiples. They have common multiples 48 and 96. The least common multiple is the least of the common multiples, so the least common multiple of 12 and 16 is 48. Important observation. The least common denominator is the least common multiple of the denominator. For example, suppose your problem 5 over 12 plus 5 over 16. The LCD is the smallest number divisible by both 12 and 16. That number is 48, which is also the least common multiple of 12 and 16. Therefore, the procedure for finding least common multiple can also be used to find the least common denominator. Least common multiple using prime factorization. You can also find the LCM, or least common multiple, using prime factorization. The LCM by prime factorization. To find an LCM for a set of numbers, follow this procedure. 1. Write down the prime factorization for each number in compact form using exponents. And 2. The LCM is found by writing down every factor that appears in step 1 to the highest power of that factor that appears. Example 9. Use prime factorization to find the least common multiple, or LCM, of 12 and 16. Solution. Prime factor 12 and 16. 12 has prime factors 2 times 2 times 3. 16 has prime factors 2 times 2 times 2 times 2. Write the prime factorizations in compact form using exponents. So the prime factors of 12 in compact form is 2 to the second power times 3 to the first power. And the prime factors of 16 in compact form is 2 to the fourth power. To find the LCM, write down each factor that appears to the highest power of that factor that appears. The factors that appear are 2 and 3. The highest power of 2 that appears is 2 to the fourth power. The highest power of 3 that appears is 3 to the first power. Therefore, the least common multiple is 2 to the fourth times 3 to the first power. Now we expand this last expression to get our least common multiple. 2 to the 4th is 16, 3 to the 1st is 3, 16 times 3 is 48. Note that this answer is identical to the least common multiple found in example 8 that was found by listing multiples and choosing the smallest multiple in common. Example 10, simplify. 5 over 28 plus 11 over 42. Solution, prime factor the denominators in compact form using exponents. 28 equals 2 times 2 times 7 equals 2 to the second power times 7. 42 equals 2 times 3 times 7 equals 2 to the first power times 3 to the first power times 7 to the first power. To find the LCD, write down each factor that appears to the highest power of that factor that appears. The factors that appear are 2, 3, and 7. The highest power of 2 that appears is 2 to the second power. The highest power of 3 that appears is 3 to the first power, and the highest power of 7 that appears is 7 to the first power. The least common multiple is the product of these highest power factors, or 2 to the second power times 3 to the first power times 7 to the first power. 2 to the second power is 4, 3 to the first power is 3, and 7 to the first power is 7. So the LCM is 4 times 3 times 7, or 84. Create equivalent fractions with the new cell LCD, then add. The fractions were 5 over 28 and 11 over 42. The LCD is 84, so to get equivalent fractions with the denominator 84, we'll multiply the first fraction by 3 over 3 since the denominator is 28, and the second fraction by 2 over 2 since the denominator is 42. Then we get in the first fraction 15 over 84, and with the second fraction 22 over 84. We add the numerators, we end up with 37 over 84. Example 11. Simplify negative 11 over 24 minus 1 over 18. Solution. Prime factor the denominators in compact form using exponents. 24 equals 2 times 2 times 2 times 3 equals 2 to the third power times 3 to the first power. 18 equals 2 times 3 times 3 equals 2 to the first power times 3 to the second power. To find the LCD, write down each factor that appears to the highest power of the factor that appears. The factors that appear are 2 and 3. The highest power of 2 to the third power. The highest power of 3 that appears is 3 to the second power. The least common multiple equals 2 to the third power times 3 to the second power. 2 to the third power is 8. 3 to the second power is 9. So the LCM equals 8 times 9, or 72. Create equivalent fractions with the new LCD, then subtract. So the LCD is 72. We want equivalent fractions with the denominator 72, so we'll multiply the first fraction by 3 over 3 since it has the denominator 24, and the second fraction by 4 over 4 since it has the denominator 18. Then we'll get equivalent fractions 33 over 72 and 4 over 72. Since we have equivalent fractions with like denominator, we can combine our numerators, negative 33 and negative 4, to get negative 37, so our result is negative 37 over 72. Of course, negative divided by a positive yields a negative answer, so we can also write our answer in the form as negative 37 over 72. Comparing fractions. The simplest way to compare fractions is to create equivalent fractions. Example 12. Arrange the fractions negative 1/2 and negative 4 over 5 on a number line, and compare them by using the appropriate inequality symbol. Solution. The least common denominator for 2 and 5 is the number 10. First, make equivalent fractions with an LCD equal to 10. So multiply negative 1/2 by 5 over 5 to get negative 5 over 10, and negative 4 over 5 by 2 over 2 to get negative 8 over 10. To plot tenths, subdivide the intervals between negative 1 and 0 into 10 equal increments. Because negative 4 over 5 lies to the left of negative 1/2, we have that negative 4 over 5 is less than negative 1/2, so we write negative 4/5 less than negative 1/2.